Beneath the golden sunlight of California lies a sleeping giant stretching hundreds of miles from the Pacific to the desert. The San Andreas Fault, ancient, patient, yet unceasingly alive, bears the strain of two continents grinding in eternal defiance. It waits, whispering pressure into stone, promising motion no human hand can stop. The Earth here is not stable ground, but a battlefield between the North American and Pacific tectonic plates. Locked together for decades, they store unimaginable tension beneath towns, highways, and vineyards. Each passing year tightens the spring, while scientists record the subtle tremors that hint at a catastrophe biding its time. Every few centuries, the fault exclaims its presence with devastating clarity, a superquake, roaring from the crust like a buried beast reclaiming its breath. Its power contorts cities, fractures mountains, and alters rivers. Still, the cycle continues, powered by forces older than humanity itself. Geologists study satellite data showing unmistakable motion measured in inches each year, invisible yet decisive. Their models simulate futures that stretch from moderate shaking to a cataclysm capable of splitting highways like ribbons. Each simulation whispers a single truth: movement is inevitable. Deep along the fault line, sensors buried beneath sand and clay transmit uneasy murmurs. These instruments record micro-earthquakes, tiny ruptures echoing like whispers from an approaching storm. They are not random, but a rising language of stress, announcing the probability of a colossal shift. Beneath Los Angeles, the ground itself hums with potential energy. Oil fields, aquifers, and forgotten tunnels weave a fragile lattice over instability. Scientists warn that this urban sprawl sits upon one of nature's most intricate fault junctions, an invisible labyrinth awaiting motion. In satellite heat maps, subtle gradients of deformation trace the invisible skeleton of pressure deep underground. Every degree of movement corresponds to immense geological torque, the kind that reshapes coastlines. Somewhere in that glowing data lies the pulse of the fault's next awakening. Pacific Ocean itself feeds this story of collision. Far offshore, tectonic plates dive and grind, channeling force inland. These undersea movements press against the Californian crust like a rising tide beneath the mountains, unseen yet unstoppable. On the ocean floor, robotic cameras capture evidence of recent slippages, fresh fissures yawning like wounds on Earth's skin. Cold mineral water seeps from them in eerie silence, carrying the smell of the deep. It is here the chain reaction may begin, too slow for sight, but too powerful for prevention. In laboratories across America, scientists recreate fault stress using scaled rock slabs, applying terrifying pressure until they fracture. The sound, amplified, resembles a sharp crack frozen in time, a preview of Earth's anger when the San Andreas finally releases its breath. They know it is not a matter of if, but when. Historical records tell of the last time this fault fully broke. In the dawn of the 20th century, San Francisco burned under flickering red skies. Streets twisted, bridges collapsed, and the coastline shifted by feet within seconds. The Earth shouted and humanity listened, powerless to halt it. Modern modeling warns that the next rupture could unleash shaking across the entire state. Power lines may fall, communications collapse, and cities could plunge into silent darkness. The world's sixth largest economy balanced on a crack, uncertain of the hour it will yield. In the southern segment of the fault, long silent, the strain is most severe. This region, stretching through Palm Springs toward the Salton Sea, has not moved in centuries. Each decade adds pressure, building an invisible mountain of stored energy yearning to split open. Salton Sea itself, shimmering under an unforgiving sun, hides geothermal vents that surge with underground heat. Scientists note the temperature changes in the water correspond to increased microquakes beneath. Nature itself seems to signal the gathering storm. Seismologists place their instruments closer and closer to the epicenter of expectation. They detect transient pulses, strange waves not fully understood, rippling through Earth's crust like precursors to awakening. The fault speaks in a coded rhythm that still eludes human translation. Across California, emergency plans lie drafted, sirens tested, but fear remains unspoken. The illusion of calm sustains daily life, as people drive highways built over fractures older than civilization. The next quake could rewrite the geography of their lives in a single violent minute. From the Sierra Nevada to the Pacific coast, invisible stress lines lace the soil like veins filled with pressure instead of blood. Everything above them, homes, pipelines, dreams, rests on tension accumulated for centuries. The ground doesn't forget, it merely delays its answer. Seismic experts track the propagation of P waves and S waves across test simulations, comparing them to ancient quakes. They predict shaking intensity that could last for nearly 2 minutes, far longer than most structures can endure. It's enough to reduce concrete to dust. In the ocean trench just west of the fault, pressure gauges detect minute surges coinciding with lunar tides. These celestial pulls, though soft, manipulate the balance of strain. Even the moon itself plays a ghostly hand in Earth's trembling future. Some scientists theorize an underground rupture might not stop at the fault's known boundaries. Violence that begins under California could cascade north or east, triggering sympathetic fractures. The continent could groan like a waking titan, reshaping itself in shared agony. Meanwhile, the Pacific coastline erodes subtly, eaten by waves whose power echoes distant seismic unrest. Shorelines retreat by inches each year, but underwater, collapsed slopes accumulate, primed for future landslides that might spawn tsunamis when the fault finally ruptures. The deep ocean sensors, powered by silent electricity, record an unnatural stillness. Sometimes stillness means stability, sometimes it means coiled violence. The sudden absence of small tremors can signal the terrifying pause before catastrophic release. Pilots flying over the fault can trace its scars slicing the landscape like an ancient wound stitched in grief. It crosses farmland, cities, forests, indifferent to human boundaries. Each viewing from above reveals how small civilization looks against Earth's unstoppable arithmetic. Beneath that scar, mineral veins shimmer faintly under laser scanning, showing heat differentials forming strange geometric shapes. Some claim these anomalies indicate friction heat preparing to ignite. If true, the planet is quietly cooking its next message to humanity. Across scientific labs, computer models render visualizations of what a magnitude 8 earthquake could look like. The simulation paints skyscrapers wobbling like reeds, bridges snapping with blinding sparks, and the coast pulling inward. The imagery silences even the most seasoned researchers. The fault line hides more than seismic threat, it harbors deep microbial life thriving in pressurized stone. These organisms feed on mineral energy, immune to sunlight or surface life. Even in chaos, nature finds persistence, turning destruction into sustenance. Scientists drill deeper, collecting core samples blackened by geological time. Each layer tells stories of prior quakes, ashes, crushed shells, compressed sands marking violent cycles. Every sample is a proof that Earth's patience always runs out eventually. Around midnight, tremors ripple unnoticed under quiet suburbs, lasting only seconds, gently rattling glass. Most dismiss them as nothing, yet they are signals rising toward climax. The planet prefers to whisper before it screams. Emergency management centers run silent rehearsals, their maps filled with red lines and flashing nodes. Each dot represents a critical weakness: water mains, hospitals, highways. The human network, so advanced, remains exquisitely fragile in the presence of the Earth's design. Meteorologists and geologists collaborate, tracking atmospheric anomalies linked loosely to deep tectonic strain. Strange ionization appears before tremors, creating eerie lights at the horizon. The sky often glows moments before the ground roars. In the darkness of the Pacific Trench, autonomous drones explore for changes in chemical composition of the water. They detect elevated gas emissions, bubbles of methane rising in slow trails. The ocean exhales warnings written in chemistry rather than sound. Beneath San Francisco, new smart sensors connect in a digital lattice, hoping to predict the unthinkable. But the data often contradicts itself, nature's algorithm remains unfathomable. The more they learn, the more mysterious the pattern of strain becomes. At night, the silence feels heavier. From the deserts to the Pacific surf, a stillness falls that almost hums. The San Andreas Fault waits beneath it all, measuring human patience against geological inevitability. When it moves again, it will not warn twice. Roads will split, coastlines will quiver, and history will divide into before and after. The giant beneath California will stretch once more, and everything built upon it will face the consequences of living atop Earth's restless heart. For now, the sun still rises over the fault's invisible wound, warming cities that refuse to tremble yet. But the countdown continues, engraved in the grinding stone below. Someday soon, the San Andreas will remind the world that stability is just a borrowed illusion.